Okay, so let us continue with where we left in the previous video. So now we in the last video what we had done was we had looked into when t pass is equal to 0, and we have understood the all three transition matrices because we have broken a time interval in 3 different steps, and then iteratively how we actually can keep on doing computation till we find our stability in the packet flow at the output of every stage, and they all once they become same, we just take whatever is our computed values and then use that to essentially measure the throughput performance of the switch. Okay. So, that was basically the method, but that is one of the extremes, that when t passes 0 and for selecting the packet to an outgoing port we consume the complete slot. There is another extreme when t select is 0. So, selection that which packet is going to go to which outgoing port happens almost instantaneously, but packet transmission does require complete full slot. Now, consequence of this is that, as we have discussed earlier, that if there are 2 packets and they want to go to the next in this current slot, decision is done almost instantaneously, only one of them will be moved out and this will require complete slot. When the next time you will in the next slot you are going to take a decision, we can decide this packet can go here, we can decide this packet can go here, but I cannot move this packet here because it will still require one full slot to transfer this packet to this outgoing port. So, you will not be able to transfer this packet here, but we will be transferring first this, and when this will be empty then only I will do the action. Now, because of this I need not split my one time slot into 3 separate steps. So, earlier I was doing separate steps because if these 2 packets would have been there when t pass was 0, this packet could have moved and this packet could also have moved. So, I was actually fictitiously created 3 steps, whereby first this packet will be exiting, second packet will be coming and the next will be happening. So, this event was happening synchronously in every time step for all stages. So, you are permitting that both of these packets actually can move. So, this can come here and this can go here, and that is why those 3 steps were there, but now we actually do not need them. So, as a consequence I do not talk about the steps anymore. So, which actually means that lot of our computation, for example, what is this P0 Ij, okay, we actually had computed this, we had computed this, we had computed this thing, we had computed this one. Now, remember when I was doing it, I was looking into what happens after step 1 in the next stage. There is no steps now. So, in fact, in the equation which we had used earlier, in same equation, instead of using P1 whatever was the state sum j plus 1, I simply replace it by 0. Same I am going to do for Pj bar. So, I will just replace all ones by 0. So, and then we will have same terms which will be coming in denominator and numerator, and we will get the same expressions except one is going to be replaced by 0. This was anyway was having the 0, this terms remains same. So, we will be only handling these 4 elements in this case, and of course, our boundary conditions now will slightly change. In that case we have to only worry about n minus second stage. So, the moment the packet is there, this is going to surely going to go out, even if 2 are contending, because it is instantaneous transmission they will all go out surely. So, Pn minus, in fact Pj, P of n minus 2 tilde was 1.0, that was my boundary condition there, but now it is no more true. So, the boundary condition which we have to use now in my computation is not this, but I will be using Pj, P of n minus 1 tilde is equal to 1.0 as my boundary condition. Okay. So, once we do it, we can now build up the state transition table correspondingly. So, first one is we call it T04. So, I can write it down. So, this is T04. So, earlier remember what I had done was I have done Tj after step 1, Tj after step 2, Tj after step 3. There were 3 transition tables which were done. I am now not mentioning J, this is for only stage 0. So, I am actually going to have 3 transition table, one for stage 0, one for stage n minus 1 and other one for any one of the intermediate stages. Okay. So, in this case, now you have to understand, when I am looking into the first stage, my arrival probability, that Pj P0 bar is always 1.0, that is my boundary condition, I am going to use that. Okay. So, once I have this, so let me see what is going to come. So, if you are in state 1 and I am talking about this stage 0, the first stage of the network. So, if your switch is in stage 1, what is going to happen? You are bound to get 2 packets in the slot, you are bound to get 2 packets with probability 1, you will end up in a situation which is either 9 or 8. Okay. So, this will be happening with equal probability, so it is half. So, I can define 1. Okay. Now, there is another thing, because in the current slot when the packet will be coming, I will be taking decision almost instantaneously at the beginning of the time slot, and I can push those 2 packets also to the output. So, these 2 actually can move to this particular output, that is one possibility, or I can actually get into a situation only one of them goes out and other one has to be held up here with the, because of the conflict, because both of them wanted to go to the same port. So, between 3 and 5 it will be happening with half probability. So, you can go from 1 to 3 actually with half probability, and you can go to 5 with half probability. Now, this is surely going to happen, there is no estimation which is required, because this is stage 0 which I am talking about. Now, if I look into state 2, then what is going to happen? So, this is a special case, the moment if a packet is available. State 2, again there can be 2 packets which can come in. So, one of the packet, if both packets wants to go to the upper port, they will not be able to go, because in this current slot this is also being transmitted out, this buffer is not empty. So, you will end up in a situation 8, okay. And so let me see what all things can happen. So, 2 packets will surely come. So, you have a packet here. So, you may end up in after the end of the slot, you will get into situation where if these both are directed on this side, then this packet will be read out, and I will end up in a situation of this kind. Or if these 2 packets are directed, both of them are being directed towards bottom. So, in that case, one of the packet will be transferred here in this current slot, this will be read out, and I will be in this situation. Okay. It is possible that I can have a scenario like this. So, this will lead to a situation that this packet will still remain here, want to go to the free port, and I will have a packet here. There is a possibility that there is a crossover. So, this will lead to a situation, this is at the beginning of the slot and this is at the end of the slot. So, I have to worry about what is going to be at the end of the slot. These packets anyway is going to come instantaneously and then they can be transmitted out. So, if this is a situation, you will have this. So, these 2 are actually same. This one and this one are 2 different cases. So, this one belongs to, let me check what is this, is the state 8, this one is state 5, this one is going to be state 6, this is also state 6. So, 8 will be happening with probability 1 by 4, this will be having with 1 by 4, this will be happening with 1 by 2. Okay. and of course, this will depend on whether this packet is going to go out or not. Okay. So, I am assuming this packet is going to go out. So, I have to write 1 over this will be P 0, okay, in stage 0 actually, tilde. So, this is what is going to happen. If the packet does not go out, then where you will be actually. So, let us see, if the packet does not go out, you will end up in this same situation. So, none of them, so they will be just contending you are here. So, this will be happening with 1 by 4 q 0 tilde, this will be converted to one packet here, this packet remains as it is, one of the packets will get transferred. Okay. So, you will come to this situation, this will be also happening with 1 by 4 q 0 tilde, and then of course, with this situation you will have one packet blocked here, other one will be here. This is the same scenario. So, this also happens with 1 by 4 q 0 tilde. In this scenario you will be having so this is also same 1 by 4. So, these three actually I can combine together. So, this will be 3 by 4 q 0 tilde, 1 by 4 q 0 tilde. So, these are 8, 5, 6, and now this particular state is state 10. Then we have next state, this one is 11, this one is 11, this one is 11. So, 11 goes by this. So, I can write down here just a minute. Oh, this is not 11, this is 7 actually, sorry, this is 7. So, let us put the values. So, 2 will correspondingly will have at 5 P 0 by 4, which is true. Then we have 6 as P 0 by 2, 7 I will have 3 q 0 by 4, 8 we will have 1 by 4 P 0 tilde by 4, then 9 and then 10th you will have q 0 tilde by 4. Okay. Let us complete the remaining ones correspondingly. So, the third one in this case in the same manner. So, third one is we have this scenario, there are 2 packets at the output. So, they both can go out, they both may not go out, and one of them may go out actually. So, with that probability, and then there is surely going to be 2 packets which are here. So, this is going to be at the beginning of the time slot. So, with probability qj square, none of them are going out, you will end up in the same state. Okay, this one actually can go. There are 4 possibilities. The both packets are staying, so they can be in this fashion. So, these 4 possibilities are there with qj bar square. So, each one of them, so these 2 are same and these 2 are same. So, this is qj tilde half qj tilde square by half. So, this actually corresponds to 14 and 13. So, this one is 14 state and this one is 13 state. So, once you understand, let me just put it down, all the values. So, from third I will be getting, so the 8th state will be there, half pj tilde square, 9th will be there with half pj tilde square, 10th will be there with half of pj tilde qj tilde, 11th will be there with pj tilde qj tilde, 12th will be there with half pj tilde qj tilde. In fact, all should be 0, not j. Okay. And then we have 13 and 14. So, this is half qj tilde square half qj tilde square. Okay. So, we can actually keep on putting it. So, the fourth one will come to 3 with half probability and 5 with half probability. Fifth will be at the sixth 1 by 2, p0 tilde, at 7th half q0 tilde, 8th half p0 tilde, and 10th half q0 tilde. Okay. Then 6th will be at the 5th location, half p0 half p0 q0 tilde. So, 7th, this actually has many terms. 7th will have with 8th state half p0 tilde square, next will be half p0 tilde square, half pj qj tilde, 11th will be pj qj tilde, 12th will be half pj qj tilde, 13th will be half qj square half qj square. Okay. So, 8th will become 5 with probability 1, 9th will become 3 with probability 1, 10th will become 8 with p0 tilde and 10th with q0 tilde. So, in fact, wherever I put j, you should just simply put 0. So, this is j is equal to 0. Okay. So, 10th and then 11th has 6th and 7th. Twelfth will be 5 and 7. 13th you will have go to 8. And 12th and 13th term will be q0 square. So, 14th similarly I can put down for this particular matrix as go to the 9th one, yeah. 11th and 14th term q0 square, q0 tilde square. So, that will be the complete transition matrix for the stage 0, and correspondingly the equation which will be there will be this. At the step k plus 1, being in state I, you will get based on the earlier calculations m is equal to 1 to 14. So, P0 m stays 0 in k T04 mi. So, this will be the equation where m will go from 1 to 14. So, for a t pass is equal to 0, we wrote a generic equation, this is for stage 0. So, similarly we can actually write down the equations for state 6 transition matrix, we write for the n minus first stage. So, we call it transition matrix 6, then we can write down 1 for in general and we call it transition matrix 5. So, I am not writing down those detailed values. So, I am giving a reference and the URL from where you can download those two matrices. In fact, you can derive on your own. So, what I will do is I will derive only certain cases for Tn minus 16 and Tj5. So, you understand the principle. Remaining thing either you can download or you can build up a matrix on your own. So, want to build up for example Tn minus 16, then what is going to happen? Let us see. Okay. So, now important thing is when you are in stage n minus 1, with probability 1 the packet will be going out if it is there at the outgoing port. Okay. So, we can take up certain cases. So, if you are in for example state 1, then what is going to happen? So, you can actually get a packet or you may not get a packet. Okay. So, that is the only possibility which can happen, there is no packet at the outgoing port. So, if you will remain in state 1 if there is no packet arrival which will happen. So, with qj bar square you will remain in state 1. If there is only one packet which arrives, other one does not arrive, then in that case you will end up in state 4. Okay. So, 4 will be 2 qj bar pj bar. So, j will be equal to n minus 1 here for this matrix. Okay. And then of course, if both the packets will arrive, then you can get into situation of either 8 or 9 with equal probability. So, 8 or 9 will be half of Pj bar square, half of Pj bar square. Remember, there is no tilde probability is coming here because this is n minus first stage. So, let me take up a case where the packet is there at the output, then what is going to happen. So, take a case of 3, what is going to happen here? Surely these two packets is going to go out, okay, in the current slot, but the two packets which will be coming in, they cannot be pushed out, they will be only coming in this particular slot. Okay. So, that is the only possibility. So, they will be coming in and they cannot be transferred out. So, these buffers are empty. At the end of this current slot, you will have only two packets here. They can be directed for the same port or they can be directed for the different port. Okay. So, let us look at that case. This will be very similar case if both the packets will come. If there is no packets which are coming in and these two packets go out, you remain in state 1, that happens with same probability. So, third one will actually be Qj bar square. If only one of the packets will come, both the packets which are at the output port will be moving out. So, you will end up in only this situation, and the same thing actually will repeat here. The second also column, the same thing will be repeating, the same thing will come. So, we can try out for something else. For example, you can say 5, let us see what will happen to the 5. So, 5 is this. So, there is a packet here which is directed here. In the current time slot, the packet, this packet will be read out surely, there is no blocking. So, exit probability is 1.0, Pn minus 1 tilde is 1.0. Okay. So, only one packet can come and it may not come. If it is not coming, you cannot transfer this packet to the outgoing side. So, with probability Qj, you will end up in a situation which is 4. You will end up in situation this, because this packet will be read out in the current time slot. If the packet arrives, this can be directed to this as well as to the next one. Okay. So, this will be coming in this current slot. So, this cannot be transferred at the same time to the outgoing side. So, you will end up in a situation. So, if the packet does come, so this can be, this packet will be going out. So, you may actually get with Pj bar, there is possibility of having these both coming on this side or these both going on different sides. Okay. So, you will have only 3 possibilities. So, from 5 you can come to 2 in this fashion. So, this will be Qj bar, and these two possibilities which corresponds to 8 and 9, no 5 and 6, sorry. So, at the beginning of the slot, this probability is the packet that will be arriving. So, in the current time slot, packet can actually moved out. So, one of the packet will be moved here. In other case, this packet will be moved here and removed. So, you will be in one of these two states. So, 5 or 6 will be there. So, with half of Pj bar and half of Pj bar, this is what is going to happen. Okay. So, you can actually build up this matrix. You can actually see this on page 280 of an article which came in IEEE transactions on computers. Volume C30, number 4, April 1991. 1981. So, in this journal on page 280 this actually 3 matrices are given. So, this particular paper is also available on sorry, this is a wrong URL. So, you can actually go here so go to this particular URL, go to Brihaspati 3 which is mentioned there, go to the open access courses, or you can actually register yourself as a student in a course on digital switching and go to digital switching. And in the course contents you will actually find out I have actually uploaded this paper and you can download and look at this particular page for the table. Okay. Now just quickly for when table is for a middle stage, it is not the last one and the first one, then you will be having both Pj bar and Qj bar and Pj tilde and Qj tilde, all 4 variables will actually be there in lot of expressions. So, I need actually case where the packet is there at the output. So, I will only look for the second one. So, this is I am talking about T5 J. I will be looking into this particular aspect if I am in state 2 where I am going to go. So, I am giving an example, this is also given in that same paper. So, this one is situation is this is the packet situation which you are there in the current time slot at the beginning the 2 packets will arrive. Okay. So, once the 2 packets will arrive they will be selected and they have to be pushed out. So, 2 packets may arrive may not arrive actually. So, you are in state 2. So, with probability Qj square you will get this one only, and with probability Pj. Now, on this probability of Pj tilde the packet will go out, you will end up in this state. With Qj tilde the packet will not go out, you will end up in this particular state. Okay. There is a possibility that one packet will come. So, one packet which can come is here, and in the current time slot this will be read out and this will also can be transferred depending on if there is no conflict. So, if this packet is directed towards this side, so this can be directed both up and down. Okay. So, this is Pj bar and Qj bar. Okay. With half probability it will be down and with half probability it will be up. Okay. So, if that happens, so if it is down then this packet will be read out and this packet will be there. So, you will end up in, and if this packet may be read out may not be read out. So, with probability, sorry this should not be, yeah this is square. So, with this probability Pj bar Qj bar, and if this packet moves out Pj tilde, you will end up in a situation where there is no packet, you have a packet at this side. You may actually, if the packet does not go out, with this probability you will have a situation when there are 2 packets at the outgoing side. Okay. So, with this half this will be happening, with half of Pj Qj bar you might be having a packet directed towards the packet which is already there. So, now this also will have 2 possibilities. If the packet goes out you will have this situation, if packet does not go out you will have this situation. Okay. If both the packets will come, so I am actually enumerating all possible cases. If both the packets are coming. Okay. So, they both can be directed to the different ports. So, cross and bar does not matter. So, this will be happening with probability Pj bar half, and there is going to be a case when both are directed to this will be happening with 1 by 4 Pj square, and there is going to be a case. So, when it is directed to like this 1 by 4 Pj bar square. Okay. So, in this scenario this packet can go out at the end of time slot and this packet can come on this side. So, packet will go out, may not go out. If packet does not go out, you will end up in having this situation. Okay. If packet does go out, you will end up in having, there is no packet on this side, there is a packet on this side directed this scenario. In this case again the same way, if the packet does not go out, you will end up in getting, so there is packet has not gone out, both of them are directed to the same port, so they will remain there. You will end up in this. If the packet goes out, you will still have both the packets stuck, and same in this case. So, this packet will not go out, it will remain there. One of the packets will come here, other one will be contending with Pj tilde if the packet goes out. Okay. So, this there will not be any packet, this packet will be contending. I have to just now enumerate by actually multiplying the probabilities. So, this is state 1, this will happen with Pj tilde Qj thing. So, let me build up. So, this one we have been doing it for 2. Okay. So, we have been doing it for 2. So, from 2 I will come to 1 with this probability Qj bar square Pj tilde. So, I can write Qj bar square Pj tilde. Okay. Now, from here if I want to come to this state, from I will come back to 2. So, anywhere else I am repeating 2? No, I am not having 2 anywhere else. So, this will have a probability of Qj bar square Qj tilde, Qj bar square Qj tilde. Now, look at this particular one. So, I have to keep on adding this state 2's. So, this is one state 2, this comes out to be, this is also state 2, there is no other state 2. So, I have to add these two. So, this will become Qj tilde square, so Qj bar square Qj tilde plus half Pj bar, sorry this one the packet has to arrive in this slot. So, this whole calculation is wrong in that sense. In the same jth slot this packet has to arrive, this cannot be moved out on this side. So, this has to end up in this particular state. Okay. So, it does not matter whether it is going on which side. So, I have to just redo this. So, this one is correct, this one is correct, right. So, this one the packet will be arriving here, it is not already present here actually, right. So, packet will be arriving in this current slot. So, this can only be directed to either the packet which is going out, it does not matter where it is directed, you will end up in this state, and with probability Qj if the packet does not go, you will actually either have this scenario or you will have this scenario. Okay. Only these two scenarios will be there, right. So, next one Yeah, packet arrives here with half probability. So, this packet can go on this side or can go on this side, these are actually same, right. So, this is state 1, this is state 2, this is state 4, this one is state 5, this one is state 5, this one is state 6, this one is state 4, sorry, and this one is state 6. Okay. So, one will be, this is for this particular combination. So, from here so this will not be going out, this will be remaining here. Right. So, this packet will not be there. This will be the scenario. So, this one is state with 2 going on different side, this is 11th, the next one is 9th, this one is 10th, this one is 10th, this one is 12th, and this one is 10th again. So, I have to just add up all the values and then put in. So, state 1 corresponds to qj bar square pj tilde, which is perfect, I have put in there. This one turns out to be state 2 is not repeating anywhere, it is qj bar square qj tilde, which is perfect. Okay. Now, look at the state 4, these two terms have to be added. So, it is half pj bar qj bar pj tilde. From this side if I go, half pj bar qj bar and with qj tilde. Oh sorry, this is also qj tilde. Okay, so you have to keep on solving in this fashion and ultimately put up the values of the matrix, and once you have this you have to again do the same iteration until you get a steady state flow, and based on that you can find out what is going to be the throughput performance. So, this is actually complicated, but so I am leaving it to you to essentially do it on your own. So, once you understand the concept you can always start analyzing the buffered system. So, in fact there is no closed form solutions, we actually do the computational procedure to estimate it, and of course the throughput is going to be better than what you are going to go with the unbuffered delta, and as you keep on increasing buffers it keeps on improving, but the incremental improvement reduces with that. So, with that we come to the end of the course. On the first one, these are basically theoretical basics on digital switching. We probably will have a digital switching 2 also, where we will be talking about actual implementations of the system, basically voice over IP telephony. So, their architecture. So, see you next time in the second course, so which it will be offered very soon. Thank you very much.